Hello, we are at our last component in the learning unit computer component for the course PRP1102 ICT Competency. And today we're actually going into studying the codings in detail, right? Now last week you have already tried to build automated physical system, right? Circuit involving Arduino, and all the microgroups able to build something that's workable, which I'm very proud of you all. And I believe, and I see all the happy faces because I went to some of the labs and actually sit there and work with you guys in the whole sessions in the lab. I can see the happy faces when you already finish your work. And so, well, for that, I'm going to select a few work and share with you today because I think it's worth sharing, right? Because there are works that is meets my expectations, and there are works that is beyond my expectations. So those I want to share, right? Now, what have met my expectation is this kind of demo, right? Now this demo I mean, if you do demo like this, you would have obtained full marks. Okay, just show a simple demo of your work, a complete process. Okay. All right. Okay, now this is a bit beyond my expectations, and is one of the work that makes inspire me to like, okay, I must share this with you guys. Okay.
Sampai habis dalam dua. Ataupun kamu makan lagi, kamu makan
So like I did not expect a buzzer to sing like that lah. I mean it will require a complicated coding. Alright. Okay, this is another one on buzzer that sings as well. Okay. So just now was some playful work, but yeah, I'm pretty happy lah that you try something that's really out of your I mean out beyond my expectation and out of the scope of the course. And this one is within the scope, and I like the way it presents the work because it shows. I mean, because any one of you can try to follow and replicate the work easily from this video, right? This demo is pretty good lah. Okay, so I'm going to share from beginning to the end. Okay. Probably I'm going to share the link to this TikTok video later. Okay, so we're going to study the codes here, right? Now, and we're going to understand better what you did last week, right? So we're going to study the code structure, right? The structure of the code. Now this is designed from previous lecture, right? And there are codings involved, pretty simple, okay. And this is also a design from previous lecture, right? Slightly complicated, right? It's longer, okay. But still, it's actually very similar to just now. We'll look into that later. This is also another design, example design from previous lecture, right? It's actually shorter. The code is shorter. What you see up here is actually just command, right? So these three codes all have something in common, right? So what are they? Okay. So we will first compare two of the codes. So the first box here is actually design 1, right? And the second one is on design 3. Let me just take away my, oops, sorry. Yeah, okay. So now you can see the label, right? So I box here, right? This is the area where we normally, right? This box here. Oh, okay. I just noticed you can't see my cursor. Let me try to find. Okay. Oh, okay. Probably I should just enlarge this. Okay, so here you can see that there I put two codes side by side, okay, and that you can notice that I square this area. All right. Now, if you look at this portions, right? Normally the one with the black font, okay. Oops. Yeah. Sorry. It should be this. Alright, so normally the one with black fonts like that, if you can, can I, oh, okay. Alright, now you will see this, you will see on this right hand side that there is alright, sorry for the interruption. So well, yes, so in this box you can see that the one in the design one is having font orange color, alright. And on design 3 here you can see that it is in black color and with a mix of you know, purple color words, right? Typical codes that is executable code, we call it, or codes that actually will affect the operating system inside your Arduino, right? Those codes will be in black color or some other color that is not orange like that, okay? Now, words that looks orangish like this, okay, is normally comments or labels or captions or whatever you call it, right? It's just text that tells you what does you know, this entire thing does, right? Especially the one at the top. Normally people will have a brief description describing what this entire code is actually doing, right? That's what people do, right? It's a typical practice, right? And here well, this design tree is not a very good coding practice because there's no explanations about what this code is actually doing, right? You have to study yourself and only you will know that, this code is probably going to play some tones and change based on sensor reading, something like that, okay? So you have to do guessing. So you waste your time, right? So people don't like to waste time, so they will do a description of coding like that. So this is what people do in the first part of the coding, is most of the time either they initialize a variable, right, or they will comment. Now what does it mean by initialize variable? Okay, now by the terms initialize variable, initialize means starting something, right? Initialize is starting something. Variable, you learn in maths, right? Is those alphabets that represents number, right? Alphabet that represent number. So in the beginning we will initialize, okay, a variable. Here the variable is sensor reading, right? Now we're going to in detail after this. Don't worry, all right? I'm just telling you what's in the first area, okay? So let's move on. Now in the second area, normally try to find the heading called void setup. Okay, void setup, right? So in this area, you will tell Arduino, right, which pin we're going to use and how are we going to use that pin, right? So here we have this pin mode, which is 12, means pin number 12, right? We want to use it as output, for example. Or if you want to use the serial monitor, still remember serial monitor, right? You must remember, okay? Now, so this serial monitor, if you're going to use, you have to begin it, right? So you write serial dot begin bracket 9600, and people will ask me, Miss, why must we use 9600 and all that, right? Now, 9600 is just a very typical number we use. It has to do with the bit transfer, okay? So 9600 is the minimum number you use. Otherwise, you can go for 115200, right? So those number will be in the Arduino IDE. Don't worry, right? If you ask me whether you need to memorize or not, at some extent, yeah, you have to like remember the number, right? If you use 9500, no, it won't work. Okay, it has to be exactly 9600, right? You can't even change one digit. Okay, so yeah. Now some other setup like that is very spatial, right? You don't have, I mean, as I mean, because you're not professional yet, right? You don't have to really go and understand every single bit of the code, okay? So normally we will take a chunk of codes from others, and we try to see how it works, how to fit our projects and all that, right? That's what we typically do. I mean, oh well, sorry, I just overshoot this thing. Hang on. So this is second part, right? We're going to the next part. So basically this part is where we configure hardware responses, right? How we want the hardware to respond, okay? Hardware typically refers to the Arduino board itself. Okay, so this last part is void loop, right? Now this portion is the action that Arduino is going to repeat over time, right? So as I explained last week, the way the Arduino will read is from the top to the bottom. It will read until the end, and it will go back up again and read again, okay? So all those actions that you want Arduino to do, you will write in this part, right? That goes under or inside the area called void loop bracket, okay? So that's the structure, right? It's always like that, okay? So if you see other structure than this, you know you're not dealing with Arduino IDE anymore, okay? So last week when some students send screenshot to me, ask me, Misa, why my code doesn't work? And when I look at the code, it looks so alien, right? It's not even, I can't even really see the words pin mode, and I can't see digital right, and the numbering is very weird. I know it's not Arduino already, okay? So yeah, so I'm teaching you that right now, okay? How to know whether it's Arduino IDE or not. So yeah, let's look at design 2 in detail. Now this is design 2, right? Design 2 has 3 LED, whereby I think the green one lights up first, right? So the green one goes first, then yellow, then red, okay? And okay, so what happened here is, first of all, well, is the initialized variable area, or it's just comment writing, oh, what is this code, right? This is C++ code, right? but no explanation on this.
Hmm.
Okay, so anyway, so on configuring hardware responses, now for the void setup, here, okay, there is four, right? There is 4 pins, and actually the last pin is a bit less obvious as the output, right? Because this LED built in, this is actually a particular point inside this Arduino, right? Whereby there is a particular point in this Arduino that control a very small LED, right, on the board. Okay, and that is what this pin mode is actually configuring, right? So that particular LED will light up, and it's actually in pin 13, right, 13. So which is why I don't advise you to use that pin in your Arduino project, right? So here we are using pin mode 9, 6, and 3, right, for output, because we want Arduino to supply 5 volt in each pin into the LED, right? So it will push voltage out to the LED, right? Which is why it's called output here. Okay, and we are going to use serial monitor for this particular program. All right. When it runs, we will see some display there. All right. So that's why the serial dot begin 9600 is there. So that's for the configure hardware responses, right? We ask Arduino to use 4 pins, right? 9, pin 6, pin 3, and pin 13, right? Namely the LED built in, okay? Of course, if you want to use just pin 13, normally we use write 1, 3. But if you want to activate the LED, built-in LED, which is kind of controlled from pin 13, so you have to write LED underscore built in like that. Okay, so that's how you will activate the built-in LED on this Arduino board. Okay, now on the void loop part, right, the process, what happened is that pin 9 will turn on first, right? So 9 high, right? 9 high. So 9 from here is actually somewhere, it should be somewhere up here, because the second row here start from pin 8. So yeah, that connects to the green one, so green one will light up first. So that will goes on, and after that the serial monitor will print the word stable, alright, and there will be some delay, right? I'm just reading through the process, okay? And then this delay, some of you might ask, okay, Miss, what does it mean by this 2000? Okay, it's not like the Iron Man I Love You 3000 kind of thing, right? This 2000 has it means milliseconds, right? Now 1000, if you write 1000, it means 1 second, right? 1000 millisecond is 1 second, so 2000 millisecond is 2 seconds, right? Now millisecond is a bit hard to measure, right? It's very short time, right? Even seconds we feel very fast already. Okay, anyway, so after 2 seconds, right? So we ask the Arduino to turn off pin 9. So the green LED will go off, right? No more green LED. And immediately pin 6 will turn on. 6 is the yellow one, okay? So immediately Arduino will turn on LED at pin 6, which is the yellow one, and the serial monitor will at that time display the text begin unstable. Alright, and after that delay for 2 seconds. Okay, now this line 21 is actually not needed, but never mind. Okay, but we're going to turn off 6, right? So 6 is going from high to low. Okay, and immediately pin 3 will turn on itself. Okay, so pin 3 is somewhere here. Okay, so pin 3 is connecting to the red LED. The red LED is turned on, and the serial monitor will print warning, very unstable. Okay, and finally there will be LED built in that's actually turned off. So which is why if you use this code, the LED built in will never turn on, because see, there's no high, right? There's no high in here. So yeah, so after that warning, very unstable is displayed after this red LED turn on, it will turn on for 1 second, and after 1 second, it will, it will not turn off because we never asked 3 to turn off, right? So which is why this LED red will turn on together with the green LED here. Okay, you can run the demo yourself. Okay, our focus today is on the process. Okay, now this design tree, right? Last week we actually look into a system with sensor, right? And I tell you, once you have a circuit with sensor, you just I mean, you just have to change the hardware, right? You don't have to change the code. So once you understand this code, right? Changing the sensor, different sensor will still work. Okay, provided you install in the right pin. So let's look at the code directly. Now in this third design, first we will initialize the variable as usual. We will initialize sensor reading. This is just name, right? If you don't like this name, you can put it as just a simple s, right? S equal to 0, also okay, right? Or you just want to write the word sense, you feel that word is cool, kind of thing. So yeah, you can give any name you want, right? But you keep that name underneath later on. Okay, you have to keep to that name that you give, right? So we initialize variable called sensor reading. Now int here, this means our variable here only takes integer, right? Now when we write equal to 0 like this, it's different from math, right? You cannot read coding like how you read math equations. It's two different things. When you read this line of code, you have to read it like, okay, first I'm going to create a variable. I'm telling this in a description manner, right? So next time you're going to describe to yourself like that. Okay? So when you see a coding that has the sign equal, it doesn't mean equal, right? Okay, this is what it says. Okay, I'm going to initialize an integer, so you type int, right? I want a variable that takes in integer. So this variable name is sensor reading, right? So I'm going to first assign, right? This equal sign means assigning, right? You give something to that variable, right? You create this variable and then you will give a value to it, right? So the value you give here is 0, right? So that's how you read the code, right? So I repeat again. So normally when you initialize a variable, you have to tell Arduino, right? This variable is integer or is it going to be float, right? If your number is like 1.25, for example, that is float, float, right? Now in this case it's just integer, so we say alright, just int, right? Our variable is int, and that variable name is sensor reading, right? Sensor reading, and I'm going to assign a value to it. That value is 0. Okay, so that's how you read the code, right? And the second part of the code is you're going to configure, you're going to tell Arduino, right, what the hardware is going to do. So this time around, we're going to use the pin 9, and we're also going to use the pin A0, right? Normally, when we have a sensor involved, right, and we're going to use A0, right, normally. But there are cases where sensor use digital pin, right? There are sensors like that. So with sensors like that, the coding portion will be more complicated, right? So if can try to avoid that, but sometimes you can't avoid, right? Because people design component to be like that, okay, with purpose, of course. I mean, who want to make life difficult anyway? So again, this code will do some printing on serial monitor. So which is why serial.begin 9600 is there. And do notice that all the lines have semicolon, right? Must have semicolon, otherwise you will get an error message say semicolon is expected at sign before something, and you're going to be panicked, right? Well, where is this, right? But of course, normally the Arduino will highlight for you which line is having error, right? Okay, so this is second portion. Okay, now the third one here is describing the action that needs to be repeated. So I'm going to line by line again. Now, okay, so sensor reading was the variable that we declare up here. Okay, so this sensor reading is going to take value from the Arduino, right? You can see this equal sign again, right? So this equal sign is not the left hand side equal right hand side kind of thing. No, okay. It's going to be like, all right, this variable is going to be assigned, right? It's going to be given something to it, right? That something is this variable, okay? Analog read A0. Now, analog read is a command in Arduino IDE where it will tell Arduino, right? Arduino is going to read, right? Read means tengok, baca, right? Dia akan ambil bacaan, okay? From this sensor, right? Which is why this sensor needs to have a 5-volt supply and a GND, right? This is to power up the sensor. The sensor is a circuit itself, and this sensor is going to produce voltages, right? And the voltages is going to into anode, right? It's going in there, and that number is going to be assigned to sensor reading. Okay, so that's the meaning of the first line. Now the next line is that you see serial dot print ln, right? And then you have this text. So what does this mean, right? Definitely you see the word serial, it means okay, this something will happen in the serial monitor. Okay, so serial dot print, so we're going to print something in serial monitor. Okay, so we're going to print the value of sensor reading, right? So this line means serial monitor is going to print that, and with the word ln that appears after the word print, it means that after the number appear, it will the cursor, because in the serial monitor there's actually a cursor moving along, right? So after printing the value of sensor reading, that cursor will go down, right, to the next line, and it will continue to do whatever it needs to do. So it's just going to print one reading, right? Then next, Arduino is going to check, right, if the value of the sensor reading is below 300, or is it more than that, right? It's a if-else structure, right? If it's less than 300, then this tone will ring, right? Otherwise, another kind of tone will ring, right? So you have experienced yourself the tone. There will be some high pitch tone, and there will be tone that's a bit low pitch, right? At the different barrier number. Okay, and yeah, and the delay is very short, right? Because we want this to have to repeat very quickly. All right. So this delay is only like 10 millisecond. It's very short seconds. Okay. So that's what happened in design 3 lah. Okay. And so you might, well, I already answered this question, to be honest. I built the code from scratch, and yeah. Even though I answered, but probably I have to demo this. Hang on. Okay, now on this screen, I'm going to demo to you that you can actually search in the website. Right here, I use DuckDuckGo search engine. Right? So in here, if you want to search for any Arduino codes, with the project that you want, you just have to you just have to type Arduino project with buzzer and LED, which is why I want you to use last week, right? Buzzer and LED. So you see a lot of projects up here, right? And definitely you can click into one of these. Which one? This one? Just going to choose one of these. Yeah, continue to site, and yeah, they will show you the connection, hardware, and coding. All right, they give you the coding together. So when you get codes from others, you have to really understand what they write, right? So like I say, identify the portion before the void setup, right? You can see that there's int buzzer here. Let me zoom this window. Okay. All right, so you can see that there's int buzzer, right? So if you recall what I said just now, this is a variable named buzzer. Is an integer, and we're going to assign a value 12 to it. All right, and we're going to ask the Arduino to set up this. Well, you see buzzer appear here, so, right? Means what? This buzzer is actually a pin number, right? So mean to say, next time if you want to change a pin to pin 8 or pin 4, you just change the number here. You don't have to change number in between, right? You see buzzer also appear here, buzzer also appear there, right? So that's the advantage of initialize variable up here. So that you just need to change the number at the top part of the code, and the rest of the code will still work, right? That's the advantage of using variable. And excuse me. So there's only one pin that will be an output, right? So inside this loop, right, the process that is repeating itself is that it's going to assign a variable, right, called I, right? Now char is a character, right? And it's an unsigned type, right? Don't worry, right? You can choose not to use this kind of I mean, at your level, you don't have to really use this type of codes, okay? And there's even while, right? So if you take codes from outside, people might use a structure that you don't understand, right? Now this while is actually something that repeats itself again, right? So repeat itself and repeat itself. So double repeat, and there's for here. For is also actually a repetitive loop, right? So taking codes from outside have this kind of risk, okay, that you have to face. But well, look at some of the codes like digital write, and there's delay, right? Now in this course, I don't really force you to really need to know all kinds of digital functions in the Arduino, right? Now this is another functions to in Arduino to actually change the status, right, of the pin. Did we? I think it's. Hang on, let me just go back to our slide and have a look. Is it digital write? Oh yeah, okay. So we did use digital write, right, to change the status of the pin from, you know, high to low, right? Okay, and let me just come back here again. And so what happened here is that for certain count, right, if okay, so you can see that this is the trick, right? So I smaller than 80, I smaller than 100. So when it's beyond 80, it will jump to the next next part of the code, right? Then it will run until it reach 100, then it will repeat again. So this is how it works down here, right? So yeah, I mean, it doesn't have to be so difficult, but if you write the code yourself, it's fine, okay? I mean, you don't have the difficulty of trying to understand more things, but it really depends what you want to do, right? So hang on. All right. So must I build the code from the scratch, right? So your answer will be, well, it's up to you, right? What you want to do for your project, okay? Anyway, I would recommend, or at least for this course, you must construct the flow of the system from the scratch, okay? Otherwise, you get lost. What am I going to type? What am I going to type in the coding, right? So it's very headache, right? It's better to design your thing from the beginning, right? If you are not that used with the shape of the flowchart, right? Probably you just write it in words first, right? You imagine it as if you have the complete design in front of you, right? How do you want this complete design to work? Right, you imagine and you write them in words, right? And once you have them in words, then you draw this. Then you will draw this flow chart. Okay. So I mean, drawing flow chart is not you directly draw. I mean, it's not like magic, right? Directly, I know what shape to draw, right? I mean, constructing flow chart is not like that, right? Constructing flow chart is the one I just explained to you, right? You imagine first, right? So for example, let's go back to this. So imagine like just now, okay? You imagine, you try to imagine this in front of you, okay? Try to imagine this system in front of you, okay? So how do I want this LED to light up, right? Do I start from the one near to the bezel here? Do I want to start the LED to light up from here first? Or do I want to light up it from here first? You know, you imagine this in front of you first, right? And then after you imagine, try to write down your imagination in simple words, right? So, or you draw out, right? Or you draw out this picture and you say, all right, this is going to be turned on 1, 2, 3. You do whatever you need to do, right? So that you can remember the process, and only we will really draw this flowchart, right? That's how you draw flowchart. You don't draw flowchart directly. I mean, just you know, okay, next one, is it this box, is it that box, is it this box? No, okay, those thinking process only comes when your the actual process has completed, right? Then you put all that in this manner, right? This manner is good for reading, right? If you are very familiar, of course it will be good for designing the flow as well. So but as a beginner like you, I would suggest you to follow the thinking process that I tell you just now. Okay. Now this flowchart we go through, we have went through before last week. Okay, I'll just go through again. Okay, so in this program, what happened is that you know, I mean when you start to draw a flowchart, we always start from this particular box called start. Okay. And then at the beginning, the buzzer at pin 9 is off, okay, it's low. Then we initialize a variable called sensor reading, right? And that sensor reading is int just now, the code just now, all right? And then it will be assigned with the value analog read A0, okay? And after that, we will serial print the value of the sensor reading, right? And then the system will detect whether the sensor reading is less than 300 or not. Okay, if yes, then it will play the pin 9 with tone 16 and go back up, right? And continue to get the reading again and continue the process, right? If no, it will get the it will output the sound at pin 9 with tone 30, right? It's different tone, and it will go back up again, right? And repeat again and again. So that's a flowchart. So I want to say flowchart is more important than writing codes itself. Like I tell you, everything that we do in this learning unit, it's all involved process, and you don't want to jumble up the process. Right? We do things step by step. Okay, and I want you to focus on the flow of another jargon came out. Right, focus on the flow of algorithm. Okay. Basically just want you to focus the flow of what's happening on your circuit, okay? So that when Arduino tells you that you need to add something or something in your code, right, you know where to troubleshoot the work, okay? Okay, so here's a briefing about your individual assignment, right? There will be assignment this week, okay? It's 4 marks, alright? You're going to have to this is what I suggested, but if you feel reconstruct is more difficult than you know come up with a new design, it's your choice. All right, now here's basically what I want you to do in this 4 marks assignment is to create a circuit with sensor. Right, now last week you create a circuit with LED and buzzer already, right? So today I want you to add, right? This week I want you to add a sensor in that circuit, and you modify the circuit slightly at the coding, right? So so let me just go through this instruction, okay? So what I suggest is you reconstruct your individual one design, right? Because last week all of you already built a circuit in the individual 6 tiles, right? That first individual one, that 6 marks, that is 6 marks, right? That tile, you already built something in there. So this week I want you to, you know, duplicate that design, right? You can duplicate the design, and or you just I mean, already have some record of what you already construct, so it's easier to do from existing one. And you do it in the new tiles, right? There's the second tiles, activity tiles, right? If you still remember, when you enter the classroom, there is 2 tiles there, right? You already create a circuit in one of the tiles, so I want you to enter to another tiles and create the circuit in there, right? So this time around, add a sensor to the design. You can add temperature sensor, soil sensor, or LDR, up to you. But I would suggest you to use sensor that use just A naught, right? And I mean, design like let me just go back to the slide before. The one I use in the design tree, right? If you choose sensor that only have VCC, GND, and one analog pin, if you have sensor like that, it's easier to modify your circuit, right? My suggestion lah. So you can choose sensor that have that kind of pin out, okay, or wiring out from the sensor. Anyway, so you have to design the response of your new system using flowchart, right? So use the thinking process I tell you just now. So from there you draw the flowchart, right? Now, as same as last week, you have to draw the flowchart, save the chart as .png or .jpeg file, upload the file in your Syswa accounts in OneDrive, okay, and insert the link, right, in the design, just like individual one, right? Ensure the link can be opened by anyone, right? Do test before you submit, okay? You don't want to lose your marks, right? Do a works and then don't get marks just because Miss cannot open the link, all right? So please do that part of your job, okay? And the last point is copy this link, right? The shareable link, and paste it into the Tinkercad design, right? Tinkercad design. So that's individual to work. Basically it's just adding sensor to your design, right? Now, last week a lot of you show me your design and ask whether that is acceptable or not, and I find that all of you already have a design with sensor, right? So I'm like, okay, that design is already for next week assignment. So if you are that category of student, right, just use that design lah, okay? Now for individual one, you must make sure you don't have sensor, okay? No sensor, please, okay? So please do changes accordingly if you did a wrong one. And if possible, individual one, don't use switch as well, right? That's not automated, right? Last week I asked for automated system, means you don't have to touch with your hand, right, at all, right? It's automated changes based on over time, right? It's automated changes over time. All right, so probably some of you might still asking me this question: what do you mean by adding a sensor to existing design, right? Let me see if I have. Okay, let me just go to the. Okay, now for example, you have this design, right? For example, you have this design, okay. So this design initially is green light up first, yellow light up first, then followed by the red one, okay? So I want you to add a sensor to this system, right? So say for example, I connect to a soil sensor, okay? So what I would recommend you to do is just forget about all this code, right? Just delete them. ask yourself, right, what does this sensor, how does this LED react based on the changes in the soil sensor? Okay, so soil sensor basically is detecting changes in the soil, right? So say the reading, well, if you don't want to imagine the real situations, you can try to get some reading, right? Because in Tinkercad, I already showed you last week that you can actually change. You can drag the toggle, right, from less moisture to more moisture. So from there, you get a different reading, right, in the anode. So find the range and decide yourself if it's less than 100 or 200. Which color of the LED you're going to display, right? If you feel 3 LED is too much, then you throw away one. Okay, you maintain the two. Right, so you can still modify. You don't have to keep exactly 3 LED, right? Just use whatever things that is making more sense, right? So but actually it can be done, right? If you maintain 3 LED, you can tell the Arduino, right, if the range fall between is falling between 100 to 300, the yellow LED will light up, right? So you it's not going to be continuous like that, but you will have an if, right? The if brackets, the reading less than 100, green one, okay. Or if it's less than 100, it's really what you want, right? If the moisture, when you drag the moisture, right, red normally is warning, right? So you are when you drag, you try to see, right, less moisture, of course that is going to be red, and you check the value lah. Okay, so normally, if not mistaken, is smaller value, right? So those range will be controlling the red LED. Then if it's between 100 to I forgot the range. And then that middle range will be yellow, and then the higher range will be green, right? So really, it's up to you to adjust, right? Just adjust with an acceptable range lah. Okay, yeah. So that's what I mean by adding sensor, right? You can add directly like that, or if you feel like 3 LED is a bit hard to code, right? You can take away one of the LED. Okay, that's how you modify the circuit, right? Let's look at the rubrics. Okay. All right, so this is a 4 marks assignment. Okay, so to get marks in this assignment, first you must make sure you have sensor in the system, right? So when I open your work, I want to see a sensor in there. Choose your sensor: temperature sensor, soil sensor, find any sensor in there. Okay, and you use the pins on the Uno board, right? Arduino Uno. So by the points, all pins chosen are correct, means to say the pins in your code and the pins on the picture are matching, right? And also match with the flowchart, right? Please, no mistake, right? Check on your pins. And flowchart and codes are aligned, right? Make sure that all the processes in your flowchart is exactly the same in the code, right? Then you will get some marks. Okay, so this is the rubrics, how I look at the rubrics. If there's anything, there's 1 or 2 things that's wrong, then your marks is reduced low. Okay, so I also put appendices in the slide, right? And this is actually from Miss Ika's slide, right, for a reference only. Okay, so that's all from me this time around. Good luck with your individual 2 assignment, and for those celebrating Raya, I wish you Selamat Hari Raya. Okay, and try to finish this as soon as possible. You don't want to sambut Raya with all these thing in the head, or have stress after Raya, right? Please manage your study lah. Okay, I wish you all the best. Okay, bye.